So Jeff here, and then Clinton there.
Okay, so this morning we heard a claim that we're going to where we've never gone before, which is costs now going up in terms of what it takes to compute. What was your reaction on hearing that, and the scale of the jump up?
This is a piece about the current.
This is when Dan talked about. Yeah. It was based on Amazon pricings, which you might not.
I'm assuming everybody's the same. So the short answer is I don't know. My focus is not on what we've got on the shelf today. It does surprise me that the same stuff is going up in price rather than the next gen stuff. But do you know, if that's where the market's going, that's where the market's going. People don't raise prices unless they found somebody willing to pay for it. But, I mean, I'm speculating. I don't have any particular. I wasn't even aware of that until Dan said it.
Okay.
That was really interesting hearing what you had to say about hyperscalers in the top 500. I almost wonder if we're going into an era where maybe we just stop caring about that so much and start caring about, say, the green 500 list, which is performance per watt. You can get a really good estimate with a fraction of the resources, so take that out of the system or have it very early on. And I almost, given where hardware is moving in terms of efficiency, sometimes there's a lot of power going to get not as much performance, and it's always that compromise. But I'm wondering if maybe some of the new points could be around, you can get this performance across all these systems, but over here you might be able to get it with much lower cost or better efficiency.
So on the green 500, it's true you can gain the green 500 by deploying a smaller fraction of your infrastructure, which is kind of what you didn't say, but what you was ahead and touched. I think so people will always still care about the top 500, and there are reasons why it still makes sense for the foreseeable future. So the fact that a hyperscaler chooses not to list on it does not in any way invalidate the list. It's always been known that there are large systems out there in the world that are not publicly listed on the top 500, and this is kind of one of those things that the fastest machine in the world is the #1 on the top 500 is not necessarily always true. It's the fastest known machine that has chosen to be submitted to the top 500 list. And the green 500 doesn't...
For civil purposes.
Sorry?
For civil purposes.
Again, so green 500 doesn't quite solve that problem, but your broader point around the cost of computing not just being measured by dollars, but being measured by environmental impact and all the rest of it is absolutely true. And kind of one of the other talks I give, we kind of go through that, and we talk about some of the non-obvious decisions you make, again, in supercomputer design, where for example, getting the PUE, we use this measure of PUE to kind of show how green our systems is, which is a bit of a fiddle at best and blatant fraud, if you want to be honest about it. And that getting a PUE from 1.1 down to 108 sounds really impressive, but ultimately made a tiny fraction of performance improvement to your system. PUE was important when everybody's data centers are running at 2 or 1.8 or something. So get it down to a 1.2-ish or 1.1-ish was important. Beyond that, it's not so valid, because the way you try and get it down from a 1.15 to a 1.1 or 108 or whatever it is by bringing into play things like liquid cooling infrastructures and so on, and then you're starting to use another precious resource, which is water. Or you start doing things like spacing stuff out, and then you're using another precious resource, which is land and so on. So the green aspects of system design is a whole game in itself as well.
Kevin.
Right here, quick question. So building a lot of supercomputers across the world
yes.
seems to be the approach you're going with. And I'm wondering, when you mention it that way, I started to think of Olympic stadiums. We build them in many different places, and then after the Olympics, so I'm just wondering, if folks have thought, or maybe I've missed it, what's the economic, social, or even environmental impact of scaling our sites this way?
All of those things. Satya is not spending $18 billion because he just found it down the back of the server and wanted to have a bash at spending it on something. It's being spent against a very clear set of objectives and what we expect the business to be, what we expect the future market to be. It's an investment against an expected return, and that return is not expected to be a 2-year thing, and then there's going to be a load of useless and wasted infrastructure as a long-term plan. So from the point of view of what do you want to call it, disused infrastructure being lying around after time, like your Olympic Stadium example. I don't think that's going to happen. The other side of things about making sure you're figuring out a long-term sustainable way to do all of this are absolutely part of it. And part of the reason that our data center costs are higher than they were a couple of years ago is because we've now got a significant investment in the environmental aspects of the technology being baked into every part of expansion that we do. So it's an interesting analogy, but it doesn't quite hold true, I'm afraid. If you can imagine, there's always, as far as we can see, there's always going to be Olympics every year. And at the moment, people want more Olympics than we can even physically build out at the moment, to kind of stretch the analogy horribly.
Jim.
So, Andrew, I like your thought experiment about the 100 megawatt data center facility. And I was thinking about, well, there are other places where energy is used, like in memory. Now, of course, memory is probably tightly attached to the it's high bandwidth memory, tightly attached to GPUs. But you didn't talk about the interconnection network. And as Dan pointed out, well, I guess it depends on your workload. If you have a real workload, you may want to pay attention to how much interconnection network performance you have, and that will then have an energy budget associated with that.
It was a very, very light example to walk through. Okay. So the real work, 100%. In fact, the real work is driven by the interconnect more than anything else. So one of the not so secrets of the AI industry is that Dan's right to some extent. The AI industry has discovered interconnects. Some players like Microsoft are on this a little bit before the others, but broadly speaking, discovered interconnects. Most of the AI supercomputers we build for training models have way more interconnect than the HPC community has ever dreamed of.
All right, good to hear.
Excellent. Well, thank you very much.